A very good afternoon to all those who are a part of this session. Wishing luck and well-being to everyone present. Myself, Kumar Sudeep, and I welcome you all here on behalf of the Accessory Design Department and NIF Mumbai fraternity. We are all so well aware of this ongoing crisis that mankind is facing. The ongoing crisis of COVID has posed many challenges to mankind globally. Across so many spheres, every industry is working hard to envisage new ways to foresee the changing scenarios and future post this pandemic. So this discussion shall give us today an insight on how 3D printing is helping the healthcare personnel to face the new challenges in these times. Let us take a look at the manifesto that this technology can impart to answer the situation of public health with a better preparation. Uh, as we know, India as a country has been a producer. One area that got affected, one of the most in this crisis, is the production. In any sector that you might name, we have been producer of agriculture products, we have been producer of jewelry, pharmaceutical products, transport equipment, machinery and instruments, ready garments, metal, electronics, rubber glass and products, cotton yarn, and fabrics, and so on. This is how we are, and this is how we are known. Make in India is the word and the meaning that we are working on and believing in. As COVID-19 affected the tourism, the real estate, automobile, and whatnot, one area that was required to face all the challenges with the health was healthcare. Salute to all the doctors, nurses, pharmacies, and all the healthcare people involved in the entire chain of activities and events that have taken place since this pandemic arose. Now, talking about 3D printing and additive manufacturing, we might know of it as a technology to scale up production, reducing time, and it becoming more and more useful and adopted due to its widespread applications in so many areas. In this discussion today, we are going to see some glances on how this technology has helped in this challenging situation to assist the committed manpower involved in healthcare with their ardent requirement in time paucity. As they say, necessity is the mother of need to innovate. Let us see how this 30-year-old technology is contributing in helping the national warriors this global war against the adversity. Thereby, myself, Kumar Sudeep, Center Coordinator, Accessory Design Department at NIFT Mumbai, on behalf of the department and the institute, shall now introduce you to the speakers. Today, we have two speakers who shall give an insight on this topic of application of 3D printing during COVID-19 pandemic. Mr. Shrikant Teli. He's our first speaker, and he's Regional Head West India at Statusys India Private Limited. He's an ambitious sales leader with over 17 years of experience of building business and maintaining loyalty with clients, vendors, external business partners, and so on. He has been driving informational programs and enabling enterprises to be future ready with cybersecurity, IoT, cloud, application lifecycle management, product lifecycle management, 3D CAD CAM, or as we know, digital twin solutions as well as 3D printing and additive manufacturing. Has also worked with companies like Oracle, IBM, Siemens, Tata Technologies, Rolta, Reliance Communication, and Datamata. Mr. Srikanth shall tell us about Statusys and what all Statusys has to offer in terms of their product package and innovation technology package that they have from their side. Then our second speaker, Mr. Ganesh Babu. He's a National Technical Manager at Design Tech Systems Private Limited. With a experience of over 27 years in the industry, he has been associated with additive manufacturing for well over 2 decades now. He has a distinction of being the first Indian to extensively work on the resin-based additive manufacturing technology. As a technical head of additive manufacturing for Design Tech Systems, he's taking care of technologies from Stratasys, SLM, and SolidScape. He has set up tool rooms and additive manufacturing departments for multiple organizations. He has been key speaker, sharing his in-depth knowledge on multiple 3D printing technologies, various forums and events. Now, with this as a premise of this discussion today, I will give over to Mr. Srikanth to share his thoughts and ideas. From him, then Mr. Ganesh shall show us through how this product package, as will be discussed by Mr. Srikanth just now, is being utilized in this crisis situation. So, uh, after that, we shall have a round of questions and answers with the speakers. With this, now over to Mr. Srikanth, please.
Yeah, thank you, Mr. Kumar Sudipto. It's a brilliant introduction. What I can hear.
Okay.
Good afternoon, everyone. My name is Srikanth Teli. I'm responsible for Stratasys business for Western India territory. And as rightly stated by Mr. Sudipto, we are in a situation of pandemic. And due to this COVID-19, the most affected part what we face during this time is during the time of lockdown is supply chain. Everything was on the same site and same place. We cannot move everywhere. During that situation, yes, you rightly said, Mr. Kumar Sudipto, that our nurses, doctors, everyone is helping the community. But as a technology giant like us, how we can help the technology? We can show in our current presentation, and to support our Prime Minister's agenda of Atmanirbhar Bharat, our technology like 3D printing technology, how we are helping other industries. We are going to present that. With this note, I would like to introduce Stratasys. As an organization, we are US based and Israel dual headquarter organization for 3D printing. We are world leader into 3D printing, and when it says that 3D printing industry for the industrial revolution, we are the pioneer of this industry. We are getting to the this situation since last 30 years, and globally we do have 150,000 plus installation of our 3D printing technology and 1,300 plus patent uh, awarded to us. Next slide. Globally, we do have more than 20,000 plus customers, which caters to the different industries, which includes medical, consumer durable. Of course, when it says that 3D printing, it's a predominantly used by automotive aerospace, but now the extensive usage during this time is not only for automotive aerospace, consumer durable, plus medical and healthcare segment is also getting benefited by using this technology. When I say that globally 20,000 customers, in India we are operating since last 21 years, and more than 800 plus clientele base. Next slide, please. Next. 600 plus customer base and 800 plus installation. When it comes to the healthcare segment in India, you name the companies like Boston Scientific, Stryker, they are using our technology for the benefits of the community. And innovation side, yes, innovative companies like GSK, Bajaj Electrical, L'Oreal, IAB is using our technology since more than a decade. Next slide, please. How our industry has helped during the pandemic situation. I would like to invite Mr. Ganesh Babu to take this ahead and explain you how we are helped during this time. Ganesh, over to you.
Well, good afternoon, everyone, and welcome to today's session for exclusive coverage for the support on for the current situation for COVID-19. How Stratasys as a technology has really influenced quite a lot of users who have decentralized 3D printed outputs that were able to be supported locally now. Well, before that, just to add on to what Srikanth was talking about Stratasys as a technology here, I'm going to present to you that Stratasys 3D printing as a solutions company addresses not just the manufacturing of automotives or aerospace. It is beyond that. It's touching medical to a very large extent today. And there we could also see students realizing their conceptual ideas, bringing forth their ideas into reality by using additive manufacturing. Well, here's a video on Stratasys as an introductory part of what they are.
To skill and industry to grow. We are shaping innovation, creativity, discovery, education, imagination, and the possibilities of tomorrow. Stratasys, the 3D printing solutions company.
So, well, I apologize for the audio disconnect due to connectivity issues, but however, there are quite a lot of other videos that will be relevant to what the agenda for today is all about. So today we'll be talking about, more importantly, on the current situation of pandemic, which has been supported very well, and how Stratasys have been front runners to come forward and associate with the partners and the customers in providing necessary digital data files or CAD data and supporting in printing parts that are being used, either you call them for face shields or whether it's going to be for PPE equipments. There's quite a lot that we are going to take a look at in today's overview. But just to add on the Stratasys overview, well over 3+ decades and dual headquarters of Stratasys at Minnesota in the US, Eden Prairie, and Rehovot of Israel. So we have dual technologies offerings from Stratasys. Both these are core technologies for additive manufacturing, which are complementing each other. And more importantly, like bringing that Indian touch to whatever Additive has been doing. Here we have the tallest, grandest Iron Man, who's our Sardar. This statue, well before being even when the consummation of this particular statue happened, probably we were able to also use Stratasys as a technology to print a scaled down model and present it to the people around, who were able to keep that as a reference, physical reference for creating such a mammoth statue. Now, while we talk about industry adaptation to additive manufacturing, there is endless possibilities with multiple verticals, starting from aerospace, automotive, entertainment industry, or when we talk about the fashion industry. All of them are well associated with Stratasys technologies today for having to realize the true benefits of using additive manufacturing in their line of work. Well, the vertical segmentation for fashion technology, while we talk about whether it is going to be quite a lot of figurines or whatever you intend to have, fashion accessories could be quite a lot in terms about being creative. All of them are quite well addressed and achieved. And I've got a few slides that cover up on the fashion front as well, apart from the medical applications that will be covered in this presentation. Now, more importantly, like consumer goods, consumer electronics, automotive accessories, gaming and figurines, all these are quite a lot of areas where these verticals are well supported with 3D printing. Now, the most important point that we are going to discuss in today's presentation is going to be Stratasys have been the first responders on the front line of the battle to stop the spread of coronavirus. And while we talk about frontline support for the battle against coronavirus, how does that happen? Because while we look at the supply chain, there's quite a lot of challenges. How do you have to overcome those challenges? How could you streamline that the supply chain, which has got a centralized facility, would definitely not be the right solution today when you look at COVID-19 support. So where do you need to do and what do you need to do? Supplier network versus centralized manufacturing sites. While you look at all of these, there have been quite a lot of limitations and there have been challenges in addressing the needs. Reason, the lockdown has imposed stringent holdback measures. You cannot ship anything, neither you can move from one place to the other. How do you address this? While looking at addressing it, the best possible way is to ensure that your manufacturing can begin with a decentralized facility. That's exactly what has been done here by Stratasys. Stratasys, with the data, whatever they have generated, they were operating through their partners, through their customers, ensuring that they receive the necessary data and the technical support. And wherever there was a need, all that what they have done is technical support, and locally at every given customer end, there have been quite a lot of supports which have been generated. One such support is from our own state of Maharashtra here, the VW plant, the Volkswagen plant. There's a video which I would like to show you right now, which caters to quite a lot of support which has been generated in Pune. Let's take a look at this particular video now.
Not much production is taking place at any of the automakers in India because they are now dedicating their resources to making equipment for healthcare professionals. This includes masks, face shields, and personal protective equipment. We caught up with Skoda Auto Volkswagen India Limited, which is making face shields, masks, and mechanical ambu bags at its facility in Chakan, Pune. I caught up with Vasan Diaz, who is the general manager and the head of ramp-up management at Skoda Auto Volkswagen India Limited, and he walked me through the entire process at the plant.
See, there are four items which we are working right now. First one being the face shield. Face shield was something which was the first requirement we received through our company, Dr. Manoj Pawar, through Sassoon Hospital. So Sassoon was one of the first hospital, let's say, Pune, to be designated hospital to treat the COVID-19 patients.
The first product is a face shield that protects health workers from droplet infections. The face shield has an elastic band and a 1 millimeter thick plastic shield that covers the face, ears, eyes, nose, and mouth. It has a foam strip for comfort. To prevent the glue from coming off, the foam is zip tied to the shield. That's because the face shields are dipped in sanitizing solution often.
So we are also working, or let's say we have also produced another item which is required by the doctors inside the operation theatre, which is called as intubation box. So normally when they insert the tubes into the patient, again there are a lot of droplets or the phlegm which comes out. So doctor again needs to be protected from those things. So
the company is also making mechanical ambu bags which help in patient respiration. This has been built with in-house materials from the car plant. The company is also making masks to supply oxygen using 3D printing.
This is one of the concepts which came up where we are working together with Decathlon. We are using this snorkeling mask and we are using an HME filter. HME filter is available in the medical store or the medical equipment shops. And between these two items, we are doing a 3D print of the adapter which goes in between and then makes a complete set which we call as filtered mask.
The 3D printed part also includes a splitter so that oxygen supply can be split between two patients at a time. The company will continue to use 3D printing to make parts for its oxygen mask, and it is supplying it to Sassoon Hospital as well as other hospitals and the police force and healthcare workers.
So that's a very interesting aspect from the automakers who have been so very creative using the Stratasys FDM 450 system for printing all those support equipments for the current situation. Similar case studies have been there from Suratkal, where ventilator components, N95 mask filters, face shields, all these from the Stratasys patented industrial 3D printers that are being used by NIT Suratkal. Now, face shields developed at GNA University. This again a case study from Design Tech associated with our GNA University. Now, the university people, again using Stratasys, the office shared system, the desktop printer for printing the face masks. Now, these face mask components, which were required to be printed on a batch quantity, have been very quickly devised, well supported by Stratasys. Similar case studies from CSIO Chandigarh. Here we have a very interesting data which has been created by the designer himself. Now, when we talk about the face shields, what is very crucial here is when it goes on from a smaller size to a large size person who's going to adapt and use it, how would you make necessary adjustments? And more importantly, when you see those slots in between those strips, these are intended designs to save on the material used in 3D printing. So cost-effective solution, more importantly, like doesn't even exceed INR 15 rupees per part. And that's exactly how they have been able to generate the entire cost-effective solutions for more commonly and more widely getting used. And Ford Motor Company is again not to be left behind. Along with GE Healthcare, they have been leveraging for creating ventilator parts. And here they get to see air pressure without electricity being generated, since they are operating on a mechanical device that has been completely generated from their in-house design. Some more on a glimpse of the global coverage. While we talk about the global coverage, the biocompatibility of the MET 610 material used in PolyJet system is ideally what has supported the cause of printing such complex lung components, wherein you can see the blood vessels, the varied sections inside, all being printed associated with certain colors in them. The face shields marks have been very, very regularly today at most of the user levels. They've been able to mass produce them, and it's a continuous production. Let us remember that Stratasys 3D printers, these are workhorses. They can go on 24/7 unattended, as long as continuous supply of power and the requisite materials are loaded in the machine, they go unattended. So these printers have been going on continuously for 3 shifts, printing and churning out parts that are supporting the COVID-19 situation. Furthermore, while we talk about COVID-19 situation, let us also try to understand what is the major challenge. Like when we talk about resource shortage, and when we talk about the lockdown as a social suspension, how does life get addressed? Now, while we look at an example of a patient, what is very much necessary for a patient is patient specific, whether it's going to be supplies or the ventilators. These have to ensure that there is reduction, there is lesser deaths, which means the mortality rate has to go down and the patient capacity has to increase by using these equipments. And when we talk about the healthcare units, ideally the protective equipments or the clinical models have to help in infection rate to be reduced. While we talk about the rate of infection to be reduced, the learning path for the PPE usage and the clinical model need to be adapted by the healthcare unit people, the healthcare workers who need to actually use these equipments for new treatment options. The adaptation is very, very crucial. And now let us go forward to look forward on the economy. Citizens in particular need to think about protective supplies and testing swabs that are going to be developed and encouraged for tests to be carried out in order to ensure that citizens' infection rate is narrowed down or reduced, and thereby you're going to fight against the case. And also you need to remove the stigma, the social tension for supply shortage, medical device supply shortage. That's exactly where it comes to address on the citizen front. But when we have to think about cooperation, what could be the best solution today? the quickest solution is definitely going to be the 3D printing solutions. And here Stratasys technologies stand up to meet those challenging times with outputs that matter more for the situation, for the current situation. Higher productivity, and more importantly, like a decentralized manufacturing, which means in-house production. You need not have to go out. We have got in-house facilities with organizations that can locally print and support. That being the case, here you get to see in this particular slide an infected lung model. While we talk about a lung model, a section which shows up as the fluid buildup is shown as a colored area. But whereas when you see at the inflamed walls, there are thickened walls of the lung that have been shown very, very clearly here in this section. These are all possible only with the multi-material polyjet technology from Stratasys. So when you're able to actually look into patient specimens for clinical study, and that too, more importantly for the pulmonary pathology, it becomes very necessary that what you scan is ideally a 2D depiction. How are you going to have more control? This is exactly where we get to see that the acute respiratory distress syndrome is better understood with the 3D printed sections. On the right, left, bottom, what you get to see is a 3D printed section, which also ensures that the patient is educated well before the treatment could begin. On the ventilator applications, we have got the ventilator machines, which are having disposable adapters. Now, these disposable adapters at the time of lockdown have been very crucial for supporting, for testing, and for supporting patients in hospitals. How could the supply chain be kept continued with decentralized facilities using 3D printing? That's exactly where, as a consumable, these air ventilator adapters have been printed and used, reason being the productivity dropped during the outbreak. And this has been well supported and equated with 3D printing as a technology. Nasal swabs, this is exclusive. Reason being the Ultim 1010 used by the Fortis production series system, the FDM technology. Here you have a customized swab. Now these have not been standard swabs under production. These new test swabs have been decentralized facilities printing them using Ultim 1010 as a material. Reason being Ultim 1010 can be sterilized at 160 degrees Celsius. Since it has a heat resistance temperature or the heat deflection temperature at 216 degrees Celsius, sterilization possible with 160 degrees C, and after autoclaving, you don't see any deterioration. And this is a very widely used and accepted material since it has low outgassing, no contamination during the testing and so on and so forth. And more importantly, it's a biocompatible material with ISO 10993 specifications, which have been tested for biocompatibility. And it also carries the USP class 6 for medical device manufacturing. Since this material goes along with the Stratasys FDM Fortis systems, ideally the best fit for printing quick turnaround. In quick turnaround time, you can print multiple swabs, test swabs for the nasal test swabs. Now let us dig a little deeper into understanding what the biocompatibility is all about. It's not just the material manufacturing that talks about MED 610 for respiratory device manufacturing. Now these device parts which have been printed with biocompatible material for polyjet technologies have been tested by Nelson Labs. Now Nelson Labs, after having to test on the various biological endpoints, cytotoxicity, irritation details, all for the testing standards of ISO, have had a test result which has been passed. And this test certificate comes along with the medical grade of 610, MED 610. Now this is the material which can get into contact, human contact, permanent contact without having any challenges for the humans. And when it comes for a mucosal contact, it can be used for a 24-hour period. And that being the case, quite a lot of areas where this MED 610 material has been used for manufacturing of respiratory device parts. Now comes the face shields, Stratasys face shields. What was Stratasys doing all the way at Eden Prairie in Minnesota? These have been, along with the Stratasys logo, quite a lot of fleet of machines, all going on 3D printing these face shields. Now the face shields, what is very critical is the plastic enclosure that comes along that needs to be actually customized. And this customization and design is given enablement for quick manufacturing. There you get to see the supplies being packed and shipped across within the US. And the same have been tried with quite a lot. And when it comes to more creative end use applications with users, today users of Stratasys technologies have had designs. For example, wherever you get to have more contact like the door handles or so on and so forth, these are some of the devices which have been designed, printed using durable FDM materials like the ABS. Strong, durable. One can actually hold these printed outputs in their pockets and carry it wherever they go. They need not have to touch the door handles, etc., when they're going to open it. Just to support them against the door and give a push. There you see the demo snapshot, which shows about how to hold that new design of the door key. And similarly, the door openers to avoid direct contact for various different designs which have been generated and been tried out. And ventilator parts. Now, these ventilator parts are all scattered as individual parts that have been printed. Now, look at this new ventilator design. Finally, when I show you the assembly of this ventilator design, quite a lot of critical components. While we talk about critical components, there is a design for additive which shows that lightweighting of parts, more importantly, complex curvatures which have been captured, quick fabrication of all these parts using durable plastics such as the ABS material, and finally they have been fastened together as an assembly. There you get to see the assembly, the critical assembly or the critical geometry parts that have been printed for the ventilator. And the snapshot of the assembly of the ventilator, only those constituting components that are complex in nature have been printed using 3D printing. The others have been fabricated with sheet metal bending and laser cutting applications, etc. More complex areas for the ventilator parts have all been 3D printed. Now, these have all been possible only because of Stratasys technologies. Now, I'm going to dwell a little bit more on the technologies that Stratasys offers. Very brief introduction to the FDM and the material jetting technology called as PolyJet from Stratasys. As I mentioned, these are two complementary technologies, core complementary technologies, ideally. So FDM stands for fused deposition modeling that comes with multiple thermoplastics. And these are thermoplastics which are in the form of filament that have been brought in from the cartridge, material cartridge into the liquefier zone before being extruded on a build platform, layer upon layer. Whereas the inkjet principle works with very fine detailed liquid material as droplets being laid on the build platform. You have finer layer thickness of as low as 14 microns going up all the way to a standard build mode of 30 microns. Fine features, multi-materials that can mix along. That's exactly a game changer today when it supports quite a lot of high-end end-use applications, so on and so forth. FDM as a technology in principle works with dual tips, one for the model material, the other for the support material. Model material is the primary material that the object intended to be printed is printed out. And the overhang features are supported during the print process by the secondary material called as a support material, which is in FDM, there are quite a lot of materials which are soluble in nature. Now, these soluble materials give enhanced outputs wherein the user can print and try to remove supports hands-free as he has to drop these printed parts in a soap type of a solution wherein with little agitation, it dissolves the support. And hence, they're called as soluble support technology, which gives cost-effective 3D printed outputs. And there's the most cost-effective solution that FDM offers today when you look at industrial 3D printing. For high strength, accuracy, durability, you can name it, and low cost applications, FDM is the best choice. FDM, the patented Stratasys industrial printer that can offer even specialty applications, food contact, biocompatibility, FST, flame, smoke, and toxicity certified materials. You can keep naming, there are many more for the FDM in principle that works along with durable thermoplastics. So material extruded, which is linear, X and Y axis, the head keeps moving, laying layer upon layer material, starting from a build thickness as low as 0.127 of a millimeter, going up all the way to the 0.50 of a millimeter. 5 different layer thicknesses with which you can work. That is the FDM technology for you.
Fused deposition modeling is a 3D printing method that makes durable objects out of the same plastics you see in everyday products. With FDM, the 3D printer takes a spool of plastic filament, melts it, and extrudes it onto a tray to build a part layer by layer from the bottom up. FDM materials are all industrial-grade thermoplastics. That's what makes the resulting parts so tough. And it's also why FDM is changing the way industries design and manufacture. With FDM, a designer can sketch an idea and test it the same day. Industries can cut lead times and costs. Products turn out better and get to market faster. FDM parts are helping to build the cars you drive. They're in the airplanes you fly in. They're in the medical devices that save lives. FDM is cutting waste in manufacturing. It's helping engineers power remote villages in Africa. It's helping farmers feed an ever-expanding population. And the ideas keep coming.
That's the FDM technology overview. It talks about the multiple verticals that it's been associated and supporting. Well, FDM product portfolio stands starting from the shared office series machines going up all the way to the production series. Anyway, from a 10 cubic inch build envelope size, you can build parts as large as 36 by 24 by 36 inches on the z-axis, which means that multi-materials on the production series machine, such as the F900. But when it comes to even the office shared systems, like the smaller versions of the desktop machines that we call, they still come with two materials. Going up the ladder on the Stratus series, you have got wider variety of material. But let's remember that FDM allows you to work with one material at a time. Reason being that you are working in a heated and an enclosed chamber. So while we talk about heating for extrusion, the material getting converted into a semi-molten state before it gets extruded onto the build platform layer upon layer can only work one material at a time. The temperatures have to be controlled so that the output qualifies to meet more stringent manufacturing applications. The classifications of materials, yes, on the F170 to the F370, you have thermoplastic urethane as a rubber material. Otherwise, you have the standard plastics, engineering plastics, high performance plastics. There's quite a lot to talk about on the performance of each of these materials that cater to varied industry verticals. Let's move on to understand what PolyJet as a technology is all about. PolyJet uses multiple inkjet heads, and each of these inkjet heads have got very fine orifice openings that dispense finer droplets of resin. These finer droplets of resin have a DPI of 600 by 600 by 1600, which means that this was for a standard 16 micron layer print. However, with the latest advancements in the technology, it offers you a 14 micron layer print. You're using UV light to convert from the liquid to a solid state of the raw materials. The photopolymer, which is UV curable, is what is used in the PolyJet technology. While we talk about Stratus, PolyJet, the J series is a game changer. While you look at some of the outputs from the J series, from concept to a detailed design or to a final design, all that on a single bed, multi-materials, the text, the colors, all that is possible with the Stratus PolyJet system. That's been the J series. You could see that various benefits, cost benefits, time benefits, and product realisms. And the only technology today to have Pantone validation. I'll talk to you more on Pantone validation in the coming slides. Well, before that, all that what you intend, whatever you conceive as a design, Stratasys J series printers can print for you. See, the PolyJet portfolio also talks about the shared office model starting from 8 base materials for the Object 30 Pro, then 12 base materials with the Object 30 Prime. However, the recently launched shared office model is the Stratasys J55. The J55 can work with a digital mode of mixing 5 materials together. 500,000, half a million plus colors, digital properties that you can apply and print your parts. Pantone validated, supported by GrabCAD Print. Well, we have the Stratasys J826 and the J850 or the J835. These are for larger mix of materials that can go along with 7 materials in a single print, and more importantly, a larger print envelope base as well. The material classification has been shown here as rigid, flexible blends. You can combine rigid along with flexible materials. You will have rigid opaque, you will have rigid transparent. So all these give you enablement for having quite a lot on achieving the value add in printing, not just prototypes, but tooling outputs as well. Here we talk about printed injection mold that inserts get printed using PolyJet as a digital ABS material. And finally, you have the end use parts. All that is possible only with the Stratasys technologies, complementing technologies, both FDM and PolyJet. So now let's move on to understand a little bit more on what the challenges in the healthcare industry is all about. Rising healthcare costs, aging population. More importantly, when we talk about using 3D printing, let us ensure that how this technology supports. While we talk about supporting, here there is a case study from Mayo Clinic that talks about using 3D printing as a surgical procedure, being well practiced with the 3D printed output, and then the solutions to cater to the patient were well addressed before the surgery could begin, and the team were well trained to work on the 3D printed part.
Brooke Hayes was in her 20s when the hip pain started.
So I stopped doing a lot of things.
Going up and down stairs hurt, walking hurt. No matter what she did, her hips hurt.
And I was cutting out everything. That's not where I was supposed to be.
She is 70 pounds and had severe deformities affecting her hips with arthritis at a very young age.
Mayo Clinic orthopedic surgeon Dr. Christopher Beauchamp says surgery to fix her hips would be complicated. Standard hip replacement implants wouldn't work. She needed a custom-designed surgery and custom-designed implants.
The press print in a three-dimensional model is made.
This is a printing press that takes information from a CT scan and layer by layer prints out a three-dimensional model of the patient's hip joint.
We are now able to take those models and actually do the planned surgical procedure on the patient's model first.
A practice run that increases accuracy during the real procedure. Then they send the model of the patient's joint to a manufacturer who makes custom-designed implants.
So that's been one of the cases where the custom implants that can be processed with a 3D printed aid, and more importantly for surgical planning, various areas that are showcased here, whether it's a heart model or the multi-material technology that supports with the inner bone as an opaque material and the exterior as a clear material. So there are quite a lot of challenges, and the value chain in the medical device, when you make a comparison to the Stratasys solutions, is huge at various areas, whether it is R&D, preclinical testing, or when it comes to clinical trials that needs to be carried out, all that can be actually done with a 3D printed output. These have been case studies like saving Mia's heart. The child is holding her own heart model from an inoperable state to an operable condition only with the aid of 3D printing. That's exactly how clinical procedures have been carried out. And very, very similarly, while we talk about clinical procedures, here's a very, very interesting case study that from Dr. Bedi. Let us hear him out. Though it is a little bit of a longer video, this is a very interesting case study from India, where GNDEC and Dr. Bedi have pioneered using 3D printing for this particular challenged patient to overcome those challenges.
Untitled Engineering College was started in 1956, and we have around 850 students at BTech level, 150 students at PG level, and about a dozen students as PhD scholars who are doing research in different fields. This manufacturing research lab was started in 2012, and we have state-of-the-art facilities in this lab. Recently, I would like to mention one case. Dr. H.S. Veddi contacted us. So he wanted a 3D image of this lung of that patient, and we did this work free of cost for him.
Now, my patient was a 23-year-old young man. His parents told me that he had been blue. So his nails were blue, his lips were blue from birth. And for some reason, he had gone to doctors, but he had not been diagnosed. But then when he came to us, we investigated him. We found that he did not have any heart disease. So his heart was normal, which is very rare to have a normal heart and still be blue. To be blue, that means blood was going to the lungs, but instead of going into the lung, where it would have picked up oxygen, it was without picking up oxygen coming back to the heart, because there was this malformation, there was this mass where the blood was recirculating. That's called an arteriovenous malformation, a pulmonary arteriovenous malformation. Because on the CT scan, it looked like a very complex lesion. There were multiple branches of the artery, multiple branches of the veins, and then in between there was lung tissue which was being bypassed. And we could not, an X-ray and a CT scan is a two-dimensional picture. So then we got to know of Professor Binder, and we came to know that he was doing some work on a 3D printing.
The doctor approached us with the 2D images, which were basically CT scan data. We used that actual data with the consultation with, of course, the medical practitioner, the surgeon. We used the standard commercial softwares for converting that particular DICOM images to the STL file, and those files were actually printed in the SC Uprint 3D printer.
Now I'll show you the print. So this is the 3D. And all these branches are exactly as they are in the body. So it is very precise, it is very accurate, and down to a fraction of a millimeter it is. Now if we did not have this view or this knowledge of, here I can know exactly what is the length of this, what is the width of this. But in actual patient, there is lung tissue on top of it. So to get to there, I will have to dissect blindly. Now because I know exactly how deep it is, I am not that blind. I am able to visualize in my brain this lesion that I am going to is exactly 1.25 millimeters deep. So I will not damage any tissue. So in conventional surgery, I will be damaging more of normal tissue because I don't know what is lying there. I'll have to dissect. So we would not have known exactly. I would have needed to go very, very slowly because I could not see through the blood through the lung. But because I could see through, because I had this model in my hand, this was actually present in our operation theatre. So it just took us, I think, about 1.5 hours. Something which would have taken 4 hours. Now, second thing is that because again we had an absolute knowledge of where the artery is, the blood loss was next to nil, maybe about 100 ml. While otherwise blood loss would have been much more, we would have needed maybe 2 units of blood. In this patient, we needed no blood. Now the patient had seen this lesion, so in his mind also he was clear what surgery is being done. And he knew both the advantages of surgery and also the risks. So it's both his parents also. And the moment we clamped this, his oxygen came back above 100, immediately, without doing anything else. So this was a great boon to us, and the patient then recovered. He was wide awake after the surgery was finished, and within 2 days we were able to send him home. And his nails, you will see, are absolutely pink. They were very good.
So it's a great help for the society and moreover the medical fraternity with respect to the 3D printing usefulness. And in future we are taking up such cases.
And after this surgery, we got 3 more cases from PGI Chandigarh of small kids less than 1 year who are having some sort of a blockage in their heart, and they want to print actually the blockage part.
So, well, with this, we move on to what the digital anatomy solution is all about. So, using the desktop printer today, Dr. Bedi and his team were so successful in treating a patient with such a challenged condition. Now, the DAP solutions is something that we talk about, whether it is the cardiovascular system or the gastrointestinal systems. All of these are well addressed. Or if you have to print any bone sections, yes, you'll be able to achieve those hard bones which are getting covered by the peristoeum, which is the softer tissue, and then you have a spongy bone or the hard bone along with the bone marrow that could be addressed and printed, because the key attributes that are well supported is the GrabCAD print. Whether it is going to be the blood vessel printing or it's going to be the bone models, all of them are well addressed. And that's exactly where you get to see a single section which has got the myocardium, the vessel walls, as well as the various areas that has to be having soft tissues are all addressed and supported well by the software. So here's this game changer that the J750 digital anatomy printer gives help for printing quite a lot of abdominal aortic aneurysms. And here from the Jacobs Institutes, there are case studies. There are a number of case studies today that we can talk about, but probably due to constraint of time, let's move on to understand where 3D printing could also associate and enable the fashion industry. Like the fashion industry adopting 3D printing, well, it is quite a long period of time. It's been more than 7+ years since Stratus's polyjet technology has been associated with the fashion industry. Here are some of the fashion industry accessories that are well supported with 3D printed outputs. More importantly, what has been conceptualized as a complex design, unable to be manufactured by the traditional subtractive techniques. It's only 3D printing that can support. That's exactly with with the images that are shown as an exclusive design, customized designs, whether it's going to be quite a lot of footwear. These are customized and creative designs. Think about the designs by Sebastian printed on the Stratus's 3D printer. All these creative outputs are only possible with Stratus's multi-material technology because it gives you texturing, and more importantly, quite a lot of fabrics that have been printed are all showcased here by models walking the ramp wearing 3D printed fabrics. And that's exactly where we look at quite a lot of accessories views that have been showcased here. And these have been printed and produced. We have locally, even with Madura garments, there have been quite a lot of work that we had carried out from Stratus's. But moving on, from the design aspects of just accessories, there are also quite a lot of innovations for architects to showcase their talents. And that's some of the outputs which are being shown here on display. Now, the J750 or the J series machine from the J750 onwards, J835, J850 and J826, all can enable you to have 100% product realism. That's exactly what you get to see from concept realization to realize your end products in a single go. Whether it's the ear parts that have the text, the logos, the colors, the labels, all these are single print outputs from the polyjet. Since they work with the vivid colors of material, the magentas, the vivid yellows, and the vivid cyans, that can give you texture simulation, leather output simulation, fabric like jeans, etc. All of them are possible to be printed in single go. While talking about the associative software that comes along with the printers are the GrabCAD print, because it enables that the complicated traditional process in order to achieve your design intent as an end reality is so very challenged that there is an easier and a smoother workflow. That's exactly how we get to work with various softwares. Today's softwares, there are multiple softwares, whether it's going to be Maya, whether it is going to be SolidWorks or CATIA. You also have GrabCAD print that can associate with KeyShot as well as with SolidWorks in order to ensure that what you intend as a design, what colors you have adopted, can really be achieved with the Pantone validated colored parts. Here you get to see one of the side scuttles for BMW Mini Cooper, customized solutions that go on in automotive. This adds value. Every customer with his unique name or logo can be printed and put upon their automotives. Well, it's truly a game changer when it comes to the industry for animation. Here we have Leica Studios talking about fully animated outputs. All these animated facial animations getting created with the PolyJet multi-material gives enablement for the animated movie manufacturing, which was earlier impossible to be carried out. And some of the characters here you get to see are true representations of what the printers can deliver in terms about the intended output. And let's now quickly look at Chromorpho collection, fabrics being designed. Chromorpho collection here talks about, this is an inspiration from a butterfly wing pattern. While we talk about a butterfly wing pattern, how does this pattern get onto a fabric? And here you get to see the 3D printed output with those designs and colors, and then stitched onto a fabric where this model is wearing a butterfly design, which is extrapolated on the fabric. So this Chromorpho collection speaks about 3D printing with PolyJet.
Approach was very different this time. 3D printing has been used in fashion for years. This time, it's a different approach because the printing is going on the surface of the fabric.
What we want to do with this project is allow the textile to carry the 3D print like fish would carry its scales on its skin. Chromorpho collection is talking about color and morphology. How does color change through movement?
We started to research different butterflies. We were fascinated with the iridescent touch of patterns and geometry of butterflies.
How do animals and insects in nature use their skin and use their movement in order to generate color? When you zoom into these insects and animals, you discover they don't use pigment, they use a microscopic structure. Nature has a morphology solution to generate the color.
Stratasys was really interested in exploring the idea of a lenticular lens. It's a small, plastic, translucent dome that bounces light through the lens in a way that if you look from one angle, you see a certain color, and if you look from a different angle, you see a different color. In this case, since we're printing in this cellular method on a fabric, we're able to print a lenticular lens as a whole collection of little islands, of little pieces on a piece of fabric, so it's fully articulated and flexible. Each of these prints has thousands of little cells. The overall garment is made of 100 to 200,000 lenses on it.
The way that it's put together is completely traditional, with a sewing machine and with binding and zipper in the back.
It's like a puzzle. You have to put all the pieces together.
But the textile itself is completely new.
We truly believe that integrating 3D printing in very thin and fine layers with the textile, we're able to have solutions that are very appealing for the fashion world.
This dress represents to me the perfect balance between craft and technology. The idea of using this new technique that Stratasys is offering, where you can see a transformation. There's something very magical and very special about this.
Chromorpho collection continues to evolve. There's another dress that we're going to show at the Philadelphia Art Museum. This is a collaboration with Julia Perla, another version of our game with butterflies and insects. Next year, we will launch 2 other evening dresses with Assemblies architects and with Mary Oxman. And more other designers will join the creatives that work with us on this thing.
So, well, that's truly great when it comes to the fashion industry, printing all those exquisite designs on a fabric, thin fabric, where today costumes get developed with 3D printed outputs. That's truly nice to hear more about, and there's quite a lot to talk in terms about the various verticals to address using Stratasys technologies, but nevertheless, when it comes to more on the engineering front, because of time constraints, we have to rush through that. Today, the tooling applications are also well supported, whether it is composite layup, tooling, soluble coats, or the coordinated tool family for the aerospace industry. We have tooling solutions for the assembly and automation line. We have metal forming applications using plastics, thermoforming applications for plastics, quite a lot to talk about with 3D printing using Stratasys, endless possibilities. Endless possibilities, and this is an area where you need to think in terms about beyond prototyping, whether you're using ABS, polycarbonate, or Ultem, each have their unique compressive load bearing capabilities that today enable you to achieve quite a lot of applications such as casting applications, or when you look at some of the areas where thin skin composite layer, all these are for the engineering benefits, or very exclusive to printing your mold inserts, printed injection mold tooling, or inserting an insert during the print process, whether it's magnets, sensors, metal inserts, RFID tags, all these are possible with special considerations working with Stratasys technologies. So multiple benefits, whether you are talking about the lattice structures, filigree structures, complex honeycomb, all of them are possibilities. Before I summarize, there is this final last video which talks about Industry 4.0 and 3D printing.
Imagine a time when intrepid astronauts traveling through space make their own 3D printed spare parts, while self-managed machines design and build whole 3D printed habitats on distant planets. Or when medical practitioners 3D print accurate models of intricate human organs and complex specialist devices for use in surgery preparation and training. Well, imagine no more. In the era of Industry 4.0, 3D printing has firmly combined with ultra-fast data transfer, cloud computing, and artificial intelligence to revolutionize the way we do business and the way we live. In the last 30 years, 3D printing has progressed all the way from to high-volume manufacturing, and Industry 4.0 is dramatically expanding its possibilities in a way that is both rapidly scalable and cost-effective. High-quality products are being designed, trialed, revised, and manufactured in a fraction of the time required by existing methods, enabling the decision-making process to become increasingly decentralized. With its high-speed connectivity, 3D printing provides industry with instant and responsive solutions. Assembled components can be made to order and produced locally, significantly decreasing the number of suppliers, labor units, and eliminating tooling costs. In creating new market opportunities and revenue streams, the adaptive flexibility of 3D printers offer manufacturers more choices in making design and business decisions. As a world leader in 3D printing technology, Stratasys delivers what manufacturers need: hyperrealism, full color, engineering grade, and a wide spectrum of materials. We streamline your product lifecycle from design and prototyping all the way to manufacturing and distribution, delivering your unique concept directly into your customer's hands. We create a unique experience that meets your business objectives and transforms complex problems into simple solutions and great ideas into great successes. At Stratasys, we put your imagination into action. Imagine that.
Well, that sums up my presentation, and I would like to invite Srikanth, and if there are any questions, we'd like to take them online, or probably if we can even address them through mail, as well as to those necessary questions that have come up from individuals, we can also address them. So there have been quite a few of the questions. If you could permit me very quickly, I can go through those questions and start answering them live. Well, while talking about is FDM the main process for making most of the products, do SLA and DLP help as well? I would definitely like to tell you that FDM is one of the 3D printing process, whether it is SLA and DLP. Well, every technology is unique in their performance. While we talk about FDM, FDM offers you a wider variety of materials. More importantly, specific to what your need is for the manufacturing applications. The selections can be made, and that's exactly how I would like to put it across. SLA has its own unique benefits, but as well as there are quite a lot of challenges when you look at a resin-based technology wherein you have to get exposed to liquid resin during the work process. Well, similarly with the other DLP and the other resin-based technologies, it's a big challenge. When in comparison to FDM, these are technologies which are more cumbersome to work with and limited to material. Material changeovers don't happen that quickly, and there is no compromise when it comes to quicker turnaround time, because post-printing, you have to get through the laborious task of support clearing and so on and so forth. So hence, FDM becomes more unique for adapting, and more importantly, as a technology that could provide you cost-effective solutions in quick turnaround time. To summarize, FDM from a cold state can begin printing in just 10 minutes from the time you switch on the printer. Well, I hope if you need more information, do try to reach out to me. I'll be more glad to answer. But Dr. Shakil again asks, which type of material is used for 3D printing? Here we talked about, all the while we talked about, these have been thermoplastics, plastics and resin-based, thermoplastics and thermoset resins in the Stratasys product line. So, well, there have been, we have another question from Naveen. You can definitely reach out if you want to learn more about TPU to my colleague in Mumbai, Mohammad Najimuddin. I would request you to get in touch with Naveen to share more information on the TPU material. Well, there is another question. How many of these PPEs could be produced in a day? Well, we talk about PPEs, it depends upon what is the type of system you're having. And probably when you look at these outputs on the FDM as a technology today, you have parts that can be printed in less than a couple of hours. So you have almost in a 24-hour print, close to around 50 plus parts that can be produced on a single machine. Well, there have been thank you messages from the other participants. I'm glad that this opportunity was provided to address your questions. But well, is there a possibility for printing an actual biological functioning organ of a part? Well, this is still in transition. There's quite a lot of research happening. We look forward to share more information as and when we would be able to gather it. Wearable textile materials from this process, that's exactly what we were talking about in the video. Wearable fabric on a thin fabric, a customized design that has been printed, and post-printing, there you get to see it is tailored to fit onto a model. So 3D printing costing, I would definitely let Srikanth to address it. Probably our printers start anywhere between 15 lakhs going up all the way to 3+ CR and so on.
It depends on your requirement, and the 3D printing machines cost is depending on the bed size, material required, and what kind of usage you do have. I would request Nazim to be in touch with questioner for this, and we will give you more details. We'll understand your application and give you more details. Predominantly, it will start from being it is built in US and Israel. We need to import this, and landing cost will be around 15 lakhs only. Any other questions? Okay, in Indian weather conditions, how effective this 3D printed fabric would be, and how long it could be woven? Depends on the application. Ganesh, if you want to add something on that,
I would like to elaborate on this. While we talk about Indian conditions or Indian weather conditions today, let us understand a new way of creating a fabric. We talk about a woven fabric upon which 3D printing has been done to bring in the designer's intent of having creativity. Now, those fabrics that cannot be traditionally manufactured is something which is complementing as an hybrid fabric. You have a fabric on which 3D printing has been done, and those have been created and crafted as a customized output. Now, these customized outputs are showcasing the creative ideas. And that means that these are not going to be worn all through the day or over a period of time. These have been intended for a special purpose of creativity in order to bring forth the ideas into reality as in physical form. Any other questions? If there are any more questions, we can take in.
You can email it to us. We will try to give answer for that questions.
I think that is the bunch of questions that we had in the forum there.
Okay.
Anything else that you people would want to specify on?
So, first of all, I would like to thank NIFT to giving us an opportunity to speak in this forum. Just wanted to add over here is an Indian perspective that 3D printing as a technology is extensively used in creative industry, and to support that creativeness from the Indian organization or Indian people, we have launched a special designed printer a couple of months back, and we are getting good response on that. And if you need any more information, for an example, somebody asked, can we have multi-material? Yes, we can have, and the color combination can be goes to the up to the 5 lakh color. None of other 3D printing machines can cater to that. So we do have that technology. If you need any help, support on information, machines, we are here to support.
Sure, Ganesh. Sure. Thank you very much, Srikanth and Nazim. So I think that will be the end of questions that we have, and any more clarifications we can take it online over the distant mode through via emails. So I think that will be it. At the end of it, at the end of the discussion and presentation, I would like to thank everyone who has been there together with us in this session. And I hope that this session was informative to the entire audience. Of course, they were from different fields. Some were from the design, some were from academics, somebody from different areas of the various layers in the professions. Of course, insights shared by Mr. Srikanth and Mr. Ganesh gave us a new perspective to look at additive manufacturing, especially the part that had to do with the coronavirus pandemic applications. That is something that really we could relook at once again, and to see further extended from here, how can we carry this application on, because this is the situation for some time at least now. Thank you both of you for sharing your thoughts and time with us. It has been a pleasure being with you this afternoon, and to see things through the lens of your expertise and knowledge. Thank you very much. And also, Mr. Mahesh Kothavale, who's General Manager at Design Tech System from Mumbai and Goa region, and Mr. Nazimuddin Mohammed, Assistant Manager Sales, Mumbai and Goa region, for all your enduring support and guidance. So throughout this planning, you were very active in the whole discussions and various phone calls and planning part that was involved. We really appreciate the efforts put in by the entire team. Thank you, everyone. Good afternoon. God bless. All be safe and healthy. So that will be all from here.
Thank you, and take care and stay safe.
Thank you, Kumar, and thank you, team. Thank you, Srikanth. Thanks all of you for joining. Wish you all to be safe. Let's work towards a safe environment for all of us to live. God bless. Thanks for having this arrangement made. Thank you, NIFT. Let's start working. Wherever there is an inquiry, please let us know. Even if it's a technical inquiry, we would love to address them. Thank you, team. Bye-bye.
Thank you. Thank you very much. Thank you, everyone.